So we are from Mahindra, and I really thank AnyLogic team for giving us setting up the stage. So yeah, next slide, please. For the next 30 minutes, we'll be talking on to the these three five topics. We'll talk about our group, the very first, and then we talk about the particular team which brought the problem or use case for us to work on AnyLogic, that is our digital supply chain management and warehousing. And then in the third topic, we'll be detailing about the project in details, and then followed by the output, and then the future plan that we are holding for the from the AnyLogic. Next step, please. So when it comes to about the group, we are from Mahindra, and as you all know, Mahindra has been operating with the different sectors like automobile, tractor and farm equipments, and even the finance, and even the IT technologies, and even the aerospace and defense. So among in that, we are a part of automobile sector. So when it comes to the automobile sector, there is a team called ADC within the automobile sector, which are based in Pune. So when it comes to the Pune, where the one of the big manufacturing plant is being there in Pune for Mahindra, where we are very proudly produce XUV 700 and Scorpio and getting production over here. So next slide, please. So so the team, which my team, I am proudly say that I'm part of a digital manufacturing team where we look after the different verticals, we supporting the production plant and helping out them here. So this is the team pick, and we are a part of this team. So we closely work with R&D and the corporate tech team, where I won't, it won't be wrong if you say that we do form a bridge between the manufacturing team and the design team, where we try to bring out their data digitally and we try to solve all their problems. We try to address their problem with the latest cutting edge technologies. So what exactly we do, that will be said in the very next slide. So this is the main portfolio or areas that we focus in our digital manufacturing team, where we focus on the very first is that manufacturing BOM, and then followed by the process planning using process simulation software. And coming to the other side, we work on a factory layout and 3D manufacture, 3D factory model, where we also do the greenfield or brownfield project, or it's something like scanning the data and then converting them into a physical model to the virtual model, so that that model will be used in a coming with the, other applications like a process simulation or 3D experience for doing the DMUs and ergo studies and everything. So in one of the field, discrete simulation is also one of among them, where I'm being part of that, and we solve the throughput analysis related problem, which directly or indirectly gonna impact or enhance the production of the plant here. So since recently, let's last from couple of months, or from I won't say like last couple of months, with along with the last couple of months with year, we've been exploring a virtual reality area, where there are some of the gaps that need to be filled through the we virtually enhancing the situation through the using headset within the team, and bringing the right stakeholders and solving the problem using the latest gadgets like a headset and everything. So we use this virtual reality also. So coming to discrete event simulation, very next slide, please. Coming to this discrete event simulation, we do use a different softwares. We've been from ages, we are using a plant simulation and flexing. But as we know, like there are some areas that we couldn't able to solve it in a plant sim. So we started exploring the AnyLogic also, and we found more interesting AnyLogic. And we are very happy and proud to say that this is the first project that we did in AnyLogic this time to one of the use case for a digital SCM, that is especially for our supply chain management, where the visualization and everything was had a very great advantage compared to other application. So when it comes to the particular use case, so I will start with the team called digital SCM team and warehousing. This is one of the team. Whenever there's a production plant being set up, and the production has been going on, obviously in hand digital supply chain management do comes together. This team actually makes sure that there's everything, the raw materials and logistic procurement to any sort of production do go hand in hand, so that the production does not get halt because of the result of the result of the change, because of the nothing drawbacks or a cut down in the the raw material that are going to supply to the production, procuring, and even the warehouse management, capacity planning, and even the supply selection, and even the manufacturing planning of the raw materials that should be given order to the vendor, and even the logistic planning also. So among this team, there's a small team that actually look after the warehouse. So this warehousing also a part of the digital supply chain team, where they look, the main focus of the team is into like to ensure that they got a adequate supply of a product, and even there's a track of a stock level of the each product. When I say each level, in the sense of individual part level, and also to see the forecast of this product coming in the coming days, or because of the raise in production volume, and also the main basic is that to ensure the and meet a daily demand. That is a ADD, we call this average daily demand. But even after doing this one, they have been the system since long many years. But why do we have to go for simulation then? Says the very first answer for that is that the faster change management. Obviously, for any small decision to change in the volume or in the way of the storage type, they need to go back to the traditional way of doing it in Excel, and then do come back with a time which actually is a more lead time. So in order to fill this gap, the digital SCM team planned to reach us, and they came with a problem statement, and we tried to give the solution to them through the model this time. So before like this, so that's the reason this AnyLogic model was created for this problem statement. So let's dive into the thing that how they right now doing in a model. What is the like current practice they're doing it out, and what's the drawback in that. So in a current practice, I would divide this complete step into a 5 category to simplify the process. So the first is that they're going to run the particular. They're going to check on a. So the first step is that they need to check in a particular warehouse. So they do enter the plant code of that warehouse and the particular area, and then do to check in SAP. Then SAP going to give the dump of data that is actually collected from the warehouse. So this data will be having all the parameters and variables, something like that name and volume and like the warehouse norms and the part size in both in XYZ direction, and even the what is the forecast is being maintained, and not the forecast as even the cost and everything. But this data will can't straight away use be able to use. They need to take out this data, then they for put into the macro Excel that is actually containing a lot of macros. That macros they will be running on top of that. That macros gives out you the proper like a cleaned up data from there, where the particular data only be taken out, and there's been calculated the space as per the logic written over there. So all these operations then later they accumulate into a summary, where at the top end, the right side, you can see that for this particular data, this is the volume that is been able to taken out. So the storage has been from like a floor or HBR or KLT type of storage. These are total square meter that's been consumed, and these are like area that is going to consume. So this is how they do the practice. So why in this practice, then why do we have to still go for a simulation then? So there is a drawback in this practice. So next slide, please. Could you please take me to the next slide? So why do you have to go for simulation then? So this complete practice depends on the Excel macro or the person who is maintaining that macro. And the lead time for any changes that you need to calculate, it's actually a more. Whenever there's a change in a volume, we suppose that you have a warehouse and you are having the data in a SAP, you export the data from the SAP. But when you want to add that, okay, this is a new volume that I need to increase, or the same data, if you need to add the the warehouse norms, or you want to increase the volume of the particular model or particular part item, then you have to enter over there and see that what is the like changes need to be happen. If it is a line item is more than a 10, 20 or 30, the person needs to add, he has to do clean up the data manually and add it on top of the main macro and do the calculation, see the calculation and to take the output of it. So it all depends on the one single person, or the data handling can be always be huge here. And when it comes to complexity, the more the data you're going to add, the more the time it's going to take. And as usual, like when the person is actually working on it, we can't trust on the data integrity and errors. There will be obviously there will be error. And when it comes to real-time data, we definitely not the real-time data because you've taken the data export from the SAP from at some point of time, and then you're putting onto that main Excel macro, and then you're searching it. So, but you can't able to. So the already the macro in a macro the formulas will be written over there. If you want to see whether this part can be stored in a floor or HPR, you can't able to do that. You again need to write a macro and do that and do the steps, and again you have to calculate everything, which is against the lead time over there. So all these, so the operational cost can go up because of not having the right amount of data at the right time, right amount of output in the sense if I need to add a small volume into the warehouse, I don't know whether can I go to that volume or not in the current existing warehouse. So that's the reason we started to build, or the team approached us to build a model for us. So next slide, please. So here the problem statement as I directly said that the main objective of this model was to conceptualize and evaluate the required warehouse space for the demand that they have. So the main objective here is that they need to first to validate the required space that has been given to a spreadsheet data, and that how do you going to validate that? So the data should be validated or need to be calculated based on the type of storages. Right now we got three types of storages. It's a floor and HBR is called IB rack, and a KLT is a form of small storage which comes just under the IB racks. And also just not only the type of storage, also the type of boxes we get here. So if you look into the bottom of the PPT, you see that type of boxes that usually you receive in a warehouse, the corrugated boxes, the metal pallet, and the plastic bin, and the PP box, something like that. So they have individual logic over there. If you come to some particular boxes, you can't store more than particular stacks over there. So all this logic need to be incorporated in the model so that it will be a one-time activity. And whenever the model is ready, we just need to put the data that is exported from a SAP and then run the model. So by this way, you're going to eliminate the time consuming behind to create the data, clean up and everything, which is going to be one-time activity while when you do the model here. So that was the main objective of this project and all these use cases. So could you please go to the next slide, please? So now we have the problem statement, and now we have the what is the objective also. Now how we are going to approach it. So the very first is that we definitely need to see how right now the team is working the conventional way, how they're doing it. You need to understand their logic, the way of macros they've written, and understand the each individual scenarios, especially when I say about that type of storages. The part can be stored anywhere also. This part can be stored straight away on a floor also. But you need to know how what is the constraint for the part to be stored on a floor. You need to also have the constraints like what is that the limit of height in HBR. What if suppose that part can be stored in a both the way? In that case, then what is the total volume consumed? All this logic need to be incorporated. So that's the reason we try to first approach them and understand them. What are the like logic that need to be followed? The second is that obviously we need a physical details like the warehouse size, actual size, aisle size, and even the what are the HBR pocket size, especially the size of the pocket, length into breadth, and what is the height limit. And when it comes to the standard pallet, directly the parts can't be stored on a pallet. It directly can't be stored on a part. The whatever the part box gonna come, you can't straight away store on a pallet. You can't have a straight on a floor, store on a floor. It need to be stored on a pallet. So the pallet will come with a standard size. You can't have the custom size of the pallet for individual part. If suppose the part is covering more than the pallet, then what is the way of storing on a floor then? Can the overhanging be taken out? Everything, those kind of scenarios and the constraints and the parameters, variables were all taken into the consideration. And also along with that, we need to know the very last point is that we need to know what is the average daily demand, what is the inventory norms, box dimension of the each part, and as already said, the type of storage and stack limit. So with all this input, we started putting the same thing, the logic and calculation into the model. That's how that we started approaching to this model. Ryan, next slide, please. Yeah. So the very first stage is that you come to the direct straight away to the calculation. This is the like the page, the right hand, the left hand side of the image shows that this is the like output that we're going to get from the SAP. That output we convert them into the input. You can see that on the right hand top. This is the like cleaned up data that is actually taken into the AnyLogic, where we have the attributes and the character. Like these are the line items from 1 to 10 in the name category, and along against them we got a length, width, height, storage type, and rack type, and everything. We have changed the parameter based on the model because they depend upon the model to categorize them or to like segregate them like one, two, three, which we know the abbreviation of them. So here actually the one says that this is a part need to go on a floor. When you say two, it means that this is the part that need to go on the HBR. So even though these details are coming up from the floor, from the Excel sheet, from the SAP, but still we're going to validate that whether it can be stored on a floor or HBR in a going further calculations. So Ryan, please next slide. Yeah. So as I said, I was talking about the type of storage. So this is the main calculations for this complete entire model. It's one of the main calculation where when it comes to the type of storage, definitely you need to have the stack limit. So on against the floor itself, we can see the image. This is the actual image taken out from the shop floor, like from the warehouse, where the parts are stored on a pallet. On top of that, they are being stored one against the other. So the very first is that they need to have the stack limit, and based on the stack limit, they need to take out the floor print, and then we got the aisle factor here, and then with the consumed floor space. So and then the floor space has been taken out. The same logic do apply for the IBA rack, where in IBA rack we will be using the standard pallet. On top of that, the parts will be stored over there, where the standard pallets have a different size. The standard pallet will be standard size. On top of that, the parts should be stored. So the main objective is that the parts should not come out of the standard pallet, so that whenever the forklift comes over there, it can easily taken out from there. The same goes with the KLT also. It has got a limit stack limit of 900 mm, and it has got a factor aisle factor of 4.00639. So all this been calculation was same been carried out in Excel, but we do the same thing in the logic also. We added all this thing in logic also. Ryan, next slide, please. Apart from this calculation, we cannot directly show the calculation whenever we try to put the data into AnyLogic and run the model. But the team insisted to want to see the movement of the data, just like the carrying out through the truck and then loading at the dock, unloading at the dock, and then HM is raised from there, take it out from there, and loading the particular stations or particular areas like a floor or HBR. So for that, we made the complete model into like to be more dynamic by writing the logic flow chart for the truck and the storing part. So that's the details that can be seen over here. And when it comes to the overall space consumed, we need to when the all the calculations been done as per the previous slide, the overall space being taken out from the by adding up the all the part item, and then we used to subtract the consumed space from the available space. The available space here is the whatever the space that we taken out as a warehouse space at the beginning of the model. Yeah, and next slide, please. Okay, so what this model actually gives, why this can't be done in a Excel sheet, but why you want to add it in a model? Well, in Excel sheet, definitely when they wanted to change some parameters, especially like when I have the standard palette of particular size like 1000 into 1000 to 1200. But if I need to change that to 1200 to 1400 to 1600, it means that the more part can be stored on top of it. But when you try to do the changes in the Excel, it need to be changed in the macros everywhere, and you need to be very cautious in that. And there are chances of getting an error also if you lose, because the Excel macro, it won't be same for all the parts over there. But when it comes to model, we had written the logic for every steps and everything, such that whatever the small changes, the static variables we say, like the constant static variables at the beginning, we are given the options in the model at the beginning itself, so that the person can change the parameters based on the changes, based on that value. The model will start calculating the output, the consumed space, especially at the end, which we called. So those values will be taken out based on this calculation, based on these parameters. So those were options were given at the beginning of the model that we can see at the right hand corner of the page, where we have given the options like what is the pallet size and what is the forklift is one of the additional part we given. That was not a part of the problem, but along with that, What is the initial stock that you want to keep it in a rack? What is the initial stock that you want to keep it in a floor and everything? And also, what is the shelves that you want to maintain in a HBR? If you whether you want to increase it or decrease it, those kind of informations or a privilege we did give in this model so that the person can use it before running the model or change it before running the model. Yeah, Ryan. Next slide, please. I had a video to show it to you here, but unfortunately, this is a PPT. I couldn't able to do that. So, but still, I try my best to explain you here. What you're seeing on the left-hand side of the image is the storage space that we are using in our it's the data been taken out from the SAP, which has been shown in the previous slides. So the part stored in the floor are the parts stored on the floor, and the parts stored in a HBR rack, which is seen on right side, bit right side of the image, are stored in the HBR. So here, what the output we taken out from here is the small, we also given the output, a statistic output from the team that what is the space consumed for individual type of storages like a floor or the for the type of HBR, and what is the total area consumed while after adding up all the type of storages, and what is the available space and everything. Next slide, please. So when it comes to the output, we did give the team in a two ways, might be in a three ways. Yes, one is that if suppose if the person select the only one kind of storage, this is actually the storage space it's going to take as per the constraints that can be stored in that kind of storage. And this is like overall volume it's going to consume that you can see on the left hand side of the graph. But when it comes to that, if you choose a mixture of type of storage, like a mix of type of storage, might be like a HBR type and the floor type and a KLT type. We did give him the details that okay, if you store in this mixture, this is like type of store. This is like total area consumed, which you can see that when you choose only one type of storage, the available space only 55% among the entire 100%. But when you choose a mixed type, obviously the floor space will be less, and the HBR was taken as per that height constraint. The HBR took a more, but still because the parts started storing in a Z direction, you need not to have the floor space. So by that time, we will definitely for this type of for this data set, we were able to show that this available space was bit reduced by 10%, and which is going to increase in the other type of storages. So along with that, just not only with the type of storage they have, along with that, we also gave that the optimized way that the model can able to calculate itself from the logic that if suppose the part need to be stored, there's a possibility to store that in HBR rather than storing on a floor, then the model calculate itself and then give the output to us. So these are the three benefits we try to give. So when we say that we change the type of storage that you are given to us from the Excel, we did exported the Excel and gave it back to them so that they can validate why can't that be stored in a flow, why can't be stored in HBR. So this was like I would say that there was a changes in the benefit was that they're able to segregate and they can able to visualize the comparison between what they were doing or what they were thinking to store and then what the model was giving back to them. So the business benefit, just like summarize the complete project in the business benefit is that there was they need not to go for Excel work every now and then. Just need to send me the format and then we run the model. We just give the output back to them in a 10 to 15 minutes. All you need to do is to create a pie chart for them in a macro, in a Excel data and send it back to them. And if they were able to easily comparison between the available space and the available the overall space consumed based on type of storage. And also the very last point is that the optimized way really helped the SCM team to look back to their calculation and also the type of storage that they're following till now. Then the model was giving back to them. So, but this is actually the first phase. When you look to the second phase, please next slide, please. Next slide. We thought of doing this kind of integration with SAP where you need not to work on the taking out the data manually so that you can just will take the data output directly from there and start giving the output for you where you are eliminating the human interaction here. Yeah, that's the model about digital SCM from the Mahindra side, and that's what we wanted to present it in this beautiful forum. And we are really open for the questions for anything from your side. And thank you.